Good morning. Welcome to my presentation. Today I talk about the effect of dust storm and Wi-Fi, on phytoplankton growth in the Southern Ocean and Tasman Sea. This talk is focused on the natural event that can remove greenhouse gases from the atmosphere. So it's very important that some natural event is actually benefit the environment, even though it's the short-term outcome may be bad. For example, like dust storm can cause health effect, and wildlife can cause property loss as well as a health effect as well. So this topic is maybe of interest for introduction. Dust storm and Wi-Fi occur frequently in southeastern Australia. The continent is dry, and there are frequent dust storm and Wi-Fi occur. Dust storm do not emit ground sequester carbon, but Wi-Fi does. Wi-Fi emit significant carbon into the atmosphere. Both of these natural events, however, they promote phytoplankton growth in the water body, for example, the ocean, when the emitted pollutant deposit on the surface water. Phytoplankton growth absorb carbon dioxide because they are plant, microscopic plant, and they from their photosynthesis they can absorb carbon dioxide. And the carbon balance of dust storm and wildlife are not very well known. So even though some of them emit, for example, Wi-Fi emit a lot of carbon dioxide into the atmosphere, but it's absorbed by phytoplankton. And when phytoplankton die, they sink into the ocean. So it's actually can reabsorb carbon dioxide. So in the future, the frequency of Wi-Fi in some area, for example, in southeastern Australia, can increase due to climate change, and it can emit a lot of carbon dioxide into the atmosphere, and it can result in net loss of carbon, and may increase the warming climate. So this study focused on the association with dust storm and Wi-Fi in southeastern Australia, in the Southern Ocean. In two particular cases, we focus here is the February 2019 dust storm event. It's a very big dust storm, and Mega 5, the complex summer Wi-Fi in 2019 and 2020. So we're using a lot of as well as modeling. So what is phytoplankton? Phytoplankton are microalgae plant. They contain a lot of chlorophyll pigment. It's the greens on the leaf, on the leaf of the tree. Example, like chlorophyll. Now there are two types of phytoplankton. They are very small plant. One is called dinoflagella, and the other one is diatom. Now diatom can grow quickly in an iron-rich environment. Dust storm have many metal element of iron and other metal in the soil. So phytoplankton, when it's fertilized with iron, it can grow quickly, and it can absorb CO2. So it's phytoplankton is similar to other plant on the land. Now, the global climate change model take into account the ocean So on the global model that we use, to predict climate change is taking into account the ocean and the role of carbon sequestration in the global carbon cycle. So, but not all of them is focused on the dust storm and the wildfire. So in this study, for example, dust storm in 2019 in February, very big, huge dust storm. You can see on the left-hand side is the satellite image of AOD, is aerosol optical depth. So it's a very big, front of storm. Dust moving across, from the desert, from the central desert in Central Australia, moving into the east coast. This dust storm is, you can see here, the satellite image is causing a lot of problem, visibility in the east coast of Australia, and the PM 2.5, PM 10 monitoring station recorded a huge concentration of dust particle. On the right-hand side here is the dust storm. This is the model. You can high split model is forward trajectory. And you can see the trajectory is from the central Australia going to move to New Zealand and actually go to Antarctica as well, into eastern and into the west. East of New Zealand in the South Pacific Ocean. Now, this is the image, satellite image of the storm from February 2019. And on the left-hand side is AOD, that is aerosol optical depth. That is the column of aerosol. On the right-hand side is the phytoplankton growth. It's detected by MODIS satellite. Now we can, using the sensor, they can detect, the green, we call the chlorophyll is usually, is green, or blue image. So after the storm, you can see the growth of phytoplankton between New Zealand and Australia. And later on, for the whole of this is the image. The previous image is from NASA, and this image is from Himawari satellite from this is Japan Aerospace Exploration Agency, JAXA. It's a similar picture to the one from NASA. So you can see high concentration of phytoplankton growth across the Pacific Ocean due to the storm. So what is a dust storm? So it's actually can improve the CO2 absorption of the ocean from the atmosphere. Now the next one, the case study is we look at the black summer 2019-2020 wildfire. This is a huge wildfire. It's occurred about 2 years ago. It's across eastern Australia. Is 5 from Brisbane, from Queensland down to Victoria. You can see one of the 2 images here on the 5th of December and on the 3rd of January. Is a peak of the 5. You can see the cloud of smoke and also aerosol as well. So what effect on this one of the 5 on you can see the burning this year only for New South Wales. You can see the area where it's burning. Now remember that Victoria is bigger than Vietnam. New South Wales is about 4 or 5 times Vietnam. So this one is actually the area of the burn is about the area of most of Vietnam. It's a huge area. can see some concentration in some of the places in Eastern Australia. You can see concentration up to very high, peak up to 1,000 microgram per meter cube. Okay, so we can using modeling to predict where the dust, where the pollutant will be deposited in the ocean. And then, from a satellite image, we can, see whether it's corresponding to the phytoplankton growth. So this is the domain that we simulate. This is the prediction and compare with observation. So it's look reasonably good prediction. And this is the simulation from our model, as well as we compare with satellite data, and we compare with NCAR in the US. They also do simulation for the whole world every day. So the corresponding to our model corresponding to NCAR model as well as the observation. When you look at phytoplankton growth, chlorophyll due to the bushfire. Oh, sorry, this one is due to dust storm. So you can see it's corresponding to the dust deposit in the ocean, and this is phytoplankton growth. This image is from Imaguari's Japanese satellite. And this one is phytoplankton growth due to the bushfire for the period in March. You can compare, this called anomaly is compare the prediction, the phytoplankton concentration, chlorophyll, with the previous, with the average of the year from 2002 to 2010. So this is the subtraction of the chlorophyll in 2020 compared with the 2002 and 2010 average. So you can see is in the first half of January is when the bushfire started. And then the second half, first half is when the bushfire is at the peak, and second half is at the end. You can see it's an increase in chlorophyll concentration, and then the first half of February and the second half as well. You can see it's increasing significantly compared to January, because phytoplankton growth is not at the peak there. And then a month later is the chlorophyll is decreasing. Most of them probably die and sink into the ocean. So we can see that there are a lot of CO2 absorbed by the phytoplankton from the bushfire, CO2 emission. So the emission of CO2 is reabsorbed into the ocean. So it actually is carbon neutral. So so the conclusion is that the dust storm and the Mega 5 in the eastern southeastern Australia is studied, and there's significant phytoplankton growth in the Tasman Sea and the Southern Ocean, and the Pacific Ocean as well. So both events promote phytoplankton growth, but the Mega 5 trigger massive growth all around the Southern Hemisphere. It's bigger than the dust storm in 2019. And the Mega 5 was much bigger and longer and emitted carbonaceous, carbon nutrient from 5, and these carbon nutrient deposit on the water surface in the ocean and promotes a very strong growth of phytoplankton. The phytoplankton bloom occurred in January and early 2020, and after that the growth disappeared. So probably nearly all carbon emitted by the Mega 5 will be absorbed by the ocean. Our study we haven't finished yet. We will using the model to predict where the pollutant will be deposited into the ocean, and then we compare with the observation. And then we can predict, how much, CO2, how many ton or megaton of CO2 will be absorbed by the ocean and emitted by the bushfire. So that's what this study is all about. It's about the natural event thus haven't been considered as part of the global climate change, but they play a very important role in regulating CO2 emission from atmosphere to the ocean. Thank you.